So hello everyone, today we'll be solving one of the problem from Geeks for Geeks. It says panagram checking. The problem is pretty simple. We are given a string and we need to return whether the string is panagram or not. So what does panagram mean? A string is panagram if and only if every letter in the English alphabet is present within the string. You take A, B, C, D, each letter, you will see each of the 26 letters are present within the string. If not, that's not a panagram string. So there are multiple ways to do this, and we will dig down each and every way how to solve this one. So stay tuned. One sweet and most uh, clear solution which we can find is we get a character ch which is initially a, and we do it till we reach z, and we at every point we see for the next character. We check if string dot contains a character ch, and if it does, then we are good to go to the next one. If it does not contains, else. If it does not contains, then we return false, and ultimately we return true because we know that the loop is finished. It means all the 26 characters are present within the string ch. How many times does the loop run? How many times the complex operation is being made? How many times the string is being iterated? The clear-cut answer goes here is it goes 26 times. The operation goes, okay, the operation goes 26 times for each of one of the character. We need to iterate the string s. So the overall complexity would be length of s into 26 characters, which is not very great. We are iterating 26 times. Do let us, so let's check whether we can do it, not 26, but only once. Only one time we need can iterate the length or not. And the answer goes yes, we can do that. But instead of iterating through characters, we need to iterate through the string. So in this case, we are iterating taking the characters not from A, B, C, D alphabets, but from the string itself. So character taking from string s dot to character array. Yeah, we are taking one by one array, and we need to take make a track where we have visited each of the letters. And did I mention that the letters are case sensitive? Those are not. So we need to keep track that the letters are not case sensitive, and we need to go ahead and store the letters. Storing a letters can be done by a very beautiful data structure of boolean array. Visited is equal to new boolean. We know that we are only going to store 26, and that's it. And first of all, we need to check whether the character we are examining is letter or not. If it is letter, then only we are going to say, but due to some reasons, if it is not letter, we are not going to process it, and we are continuing to the next, continuing to the next one. Now we are sure it's a letter. Do make it within the lowercase. So lowercase letter is char lower letter. I'll say so. I'll say character dot to lowercase ch. Yep. Now I need to store the lowercase letter. So let's store visited of lower letter minus a. Why minus a? Because I need to store the index, and ASCII value of a small a is not 0. So making it to 0, I need to minus it from the a itself. So I've seen it, I've visited it, so let's mark it as true. Now I'll reiterate from each of the visited array, each of the letters from the visited array, and I'll say for visit, and let's take it as boolean visit within visited, and I'm saying if visit, I've not visited is, if it is false, that means not true, then return false. else we are going to next, we are going to next, and ultimately we'll keep ending. We'll reach the end of the array, we'll get out of this loop, and we'll return true in that case. Yeah, that works in this way. Let's submit this to check it. But hang on, there is one more better way to deal with this solution. Yeah, it works very well. It works very well. But my friend, we are maintaining an array. What if we do not even want to maintain an array? You will ask me, hey, what are you saying? If we do not want to maintain the array, how will come to know that we have seen each and every array? So there's one trick. We have only 26 characters, only 26 letters. So we need to store only 26 ones, isn't it right? And ultimately post it our valid string or our valid string, let's say array or boolean array for that matter, would be 1 1 1 1 1 till 26 times. Isn't that right? So why don't we take, instead of an array, we take a number? So you might ask, how is it possible? So let me be clear over here. I'll say int required is equal to 1 to the shifted 26 digits. So now we have shifted 1 to 26 digits. It will see something like this: 1, 0, 0, 0, 0, and so on till 25 characters. But we do not want that. Sorry, 26 characters. But we do not want that. We want one less. So required minus equals to 1. This will create a string something like this: 1, 1, 1, 1, 1, 1, till it will take 26 characters. The earlier it was 27, right? So do you see any similarity between this and this? I do, I do. And I see that instead of the valid string or valid array, we can use only a single integer. So let's do this. Let's do this. We don't want an external space, so let's remove this. We still need to iterate each of the character, but hold on for a second because we are not iterating entirely. This is the worst case where we iterate the entire length. So we'll say it as worst case. A best case, you might ask. Best case is something only 26 iterations where you have A, B, C, D, E, F, G, H, and so on till Z. This is the best case input which we will get. Huh? Case ignored within this. Yeah. Now, we also wanted to store this array. This is the required array which we want, right? We need to store the current situation. So current situation is equal to 0 initially. Why 0? Because we haven't seen any of the letters so far. Notice the first letter within the reverse order will indicate, like let's suppose this one, the last one would indicate A and the first one would indicate 0, Z. So in this manner, we'll have 1, 2, 3, 4, and X, Y, Z in that case. Makes sense, right? So let's get forward. I've created a lowercase letter. I have used a visited array. Let's not go ahead and use it. I'm saying I'll use current situation, and I'm incorporating the one which we have got, and I'm using this left shift. Left shifting of lowercase letter index. How I will get the index again, you might ask. Then the index can be found very well by subtracting it with A, as we did earlier. So we subtracted with A, we found the one shifted to these many letters or these many numbers, and we have accumulated with within the current situation. Now one thing, a smart move we can do over here, not require, it's on optional, that we can check the current situation is equal to required, uh, what is the spelling I have used over here? Required. And if it is true, then return true. Ultimately, it might happen that entire string is being iterated, but it's not matching to the required sum, or it might match. So in this case also, we are going to go ahead and return this. If it is true, we are returning true. If it is false, we are returning false in that case. So let's try to run this. It says we have an error. We want a semicolon. Post this. Where is the semicolon missing? Line number 22. Oh yeah, line number 22. Here it is. So yep, we have passed this. Let's check for the rest of the test cases as well. Meanwhile, let's discuss the time complexity. The time complexity is, in average case, it is equal to number of letters contained within the string, and within the space, it's O of 1. We are using only one and two variables, and that's all we have. That's it. That's it. So this was about it. If you wanted to know how we can convert anything to integer, then click the video upon your right, and I'll see you in the next one.